Okay, so here's section 1.4, part 2, and notice all the words. So we're again getting you ready for some story problems, but we're starting off very basic for right now. So for number 7, again, just like within the previous section that we did, it says just translate using numbers and symbols. So a quotient is the answer to a division problem. Quotient means you're dividing. So if I want the quotient of x and 3, that's simply going to be x over 3. Write your division problems as a fraction. Do not use the little division symbol. Write it as a fraction. B, a number n divided by 5 would be n over 5. Let's look at 8. 2 times x minus 7. Well, that would simply be 2 times x, and then we're going to subtract 7 from that. Now, where it becomes interesting is when we now go to B, and it says 2 times the difference of x and 7. So difference, first of all, means that's a subtraction problem, so we have to know that. Now, there's a S missing here, isn't there? So what do we need to do? We need to do 2 times the difference of x and 7. So the question is, what are we multiplying by 2? We are multiplying the whole difference of x and 7. So the difference of x and 7 would look like this, x minus 7. Now, how would I represent that I want to multiply that whole thing by 2? I would have to put it in parentheses and multiply it by 2. So look at the difference between these two answers. In A, I was just multiplying the x by 2. B, I'm multiplying the whole difference of x and 7 by 2, so I need parentheses there. That's pretty important. So those are all what we call mathematical expressions. There's no equal sign. So these answers are all expressions. There's the word. Now let's take it one step further and let's look at what an equation is. Well, an equation is a mathematical sentence that contains an equal sign. There's the key. An equation will always contain an equal sign. What we do with equations is we solve them and we find solutions. So a solution to an equation would be the number or numbers that make the equation true. So for example, an equation might be n plus 3 equals 7. That's an equation. If I were to solve this equation, I would want to know what number would fit into there for n that would make it true. And I think we can all agree that n would have to be 4. Now, we will get into much more difficult equations. We will get into equations that have more than one answer. But for right now, we're just starting off simple. In fact, if you look at number 9, all we're doing, it says, is translating each sentence into an equation. It doesn't even say we're going to solve the equation. But spoiler alert, we may as well. So, 9a, what number squared is equal to 25? So what number? So that's going to be our variable. I'm going to choose to use n as my variable for these problems unless it tells me different. So what number squared? That would be n squared is equal to 25. There's what that equation would look like. What is that number, by the way? It would be 5. How about B, sum? Now, sum means the answer to an addition problem. So that means we're going to have some addition. The sum of what number and 10 is equal to 50? Well, my what number is going to be n. The sum of that number and 10 is equal to 50. There's my equation. And we all know that number is 40, by the way. The quotient, we already talked about this word. Remember, that means division. The quotient of 18 and what number is equal to 6? So that would be 18 over n. There's the quotient of 18 and some number is equal to 6. And again, if we were to solve that just by looking at it, we can see that that answer would be 3. Our last example in section 1.4 says, is 7 a solution to this equation? Well, when we defined solution, we said that a solution was a number that made the equation true. So how am I going to tell if 7 is a solution of this? I'm going to plug it in for x. There it is. And I'm going to see if I end up with a true statement. Do I? What is 15 minus 7? It is 8. So yes, it makes a true statement, which means yes, it is a solution.